section 4.1 talks about graphs of sine and cosine functions. Now, as far as why we're even looking at this and how this relates in real life, the motivations include things like predictable weather patterns, tides, hours of daylight for you people in the medical field, heartbeats. All of these can be represented with periodic or repeating functions. Our objective here is to look at the graphical representation of sine and cosine, which are two of our 6 periodic functions. In essence, we're going to be looking at what we did in 3.3 with the unit circle, and we're going to be rolling that out onto the Cartesian coordinate plane, where x is going to be given a radian measure, and y is going to be the value of the trig function evaluated at typical points. Now, I'm going to put this link here, this one in blue. Now, it may not actually be a link. You can actually just highlight this, copy it into your thing, and I want you to go and I want you to look at it. There's the directions for actually following this little thing, but it shows you how to directly associate what's on the unit circle with what we're going to lay out in the graph. And I want you to just stop yourself right now and go and look at this link and play around with this. It's not exact, but it's very close. But I want you to go play around with it and see how they are related, and then come back and finish this video. So just take yourself a pause, go do this, and then come back. Okay, hopefully you've been to look at the way that actual video just lays that unit circle out along the XY axis. Now we're going to do this by hand so that you'll know exactly what's going on between the two. We're going to start with sine. And remember that one complete trip around the unit circle is 2 pi in length. So one period for sine for us is 2 pi. And we're going to do what is known as a t-chart. We're going to create a t-chart, picking key values for the trig functions. Now, a t-chart, typically you pick x values and you find y values. What we are graphing, I maybe not use f of x, we're going to graph very basic y equals sine of x. So some things that you're going to pick: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now you could obviously fill in some gaps there. You know what pi over 3 is, and pi over 6, and pi over 4. You could pick any of those. But we're going to concentrate on just these 5 pivotal points while we're figuring out what this would be. Now these are actual radian values, so you should know the sine of 0, when this is in radians, would just be 0. So my first point I'm going to plot is 0, 0. Okay, if I take y equals sine of pi over 2, well, that's the same thing as y equals sine of 90 degrees. And hopefully you know the sine of 90 degrees would be 1. So my next plot would be pi over 2 and 1. Then I would want to find y equals sine of pi. Well, that would be y equals sine of 180 degrees. And when I figure that up, that would be 0. So you can definitely look at that either in your calculator or even on a graph or the unit circle as we have talked about previously. Y equals sine of 3 pi over 2 is the same as y equals sine of 270, and the y equals sine of 270 is actually negative 1. And then lastly, y equals the sine of 2 pi. Well, I forgot my sign. Y equals the sine of 2 pi. Well, 2 pi and 0 give you the same result, so you're just going to get 0 again. And we've made one complete loop around the unit circle, only picking pivotal points. We actually picked our quadrantal angles. That may bother some of you, but just hang with me. So the x-axis is going to be labeled with these values in radians. I'm going to try to mark these off as equally as I can. 2 pi is the whole length that I'm looking at, starting at 0 to 2 pi. Halfway between there would be pi. Halfway between 0 and pi would be pi over 2. And halfway between pi and 2 pi would be 3 pi over 2. Now think about this, guys, just a side note. For counting, this is 0 and a half. And this is 2 halves, which would be 1. And this is 3 halves. and this is 4 halves, which would be 2. You're just incrementing by those halves. Okay, so that's why those are set out like that. The pi's just tag along. Now I'm going to erase these because they're not extremely important. I just wanted you to make that note of we're incrementing repeatedly. Now, my y values are different. They're 1 and -1 is 0. Alright, so let's plot these points. 0, 0, of course, is right here. Pi over 2 is the x value and 1 is the y value. That point would be right here. Pi and the value of 0 would be right here. 3 pi over 2 is x, and y being -1 would be down here. And then lastly, 2 pi is x, and y being 0 would be back here. My sine curve is going to go somewhere like this. Now, just for sake of argument, I know that between 0 and a half is a quarter, or more importantly, pi over 4. So I want to just see if I'm in the right area. If I wanted sine of pi over 4, which is sine of 45 degrees, 45, 45, 90, that'd be 1 square root of 2. That would be 1 over the square root of 2. When I put that in my calculator, do I even have a calculator today? No. When I put that in my calculator, I'm going to get square root of 2 over 2, or I'm looking for me a decimal. Hold that thought. Oh, I hate it when I forget that. Alright. Okay, that is approximately 0.707. I went and grabbed the calculator real quick. So, if I look at a half, am I approximately in that zone? Yes, I really am. So that gives you an idea of the fact that we're covering those other values that we know in the unit circle, but we're just hitting those big 5 right here in the red. Now in the blue. Let's go back to red. These are the ones that are pivotal. Try drawing the sketch. This is the basic sine curve. Now we limited ourselves to one period. This is one period, but this thing keeps going. And it keeps going this way. Okay? So just be aware, we're just looking at one tiny glimpse of it right here. Alright, let's look at sine's attributes. From your graph, you can see domain is negative infinity to positive infinity. What do I mean by that? Well, I hadn't drawn all crazy over this. This is the x values here. And like I said, we're going to continue to go on down the graph this way and this way. So positive infinity is out this way, negative infinity is out this way. And so that's how we say domain is positive infinity. This should be negative infinity. Everybody make a note here. Domain is negative infinity to positive infinity. I do apologize. That negative did not get translated. Neither did this one. I actually made this one time and then I lost it and I recopied and pasted and things were lost. I should have checked it more closely. Both of these should be negatives. Apparently the negatives were gracious. Apparently the negatives were just lost altogether. I'm sorry guys. Okay. Range is 1 to 1. Range deals with y values, and so the topmost y value that this went through was positive 1. The bottommost y value was negative 1, and that's why we say range is negative 1 to positive 1. The period is 2 pi. Again, after this length, the function repeats. Okay, so to get a whole complete round is 2 pi. Once you hit that 2 pi mark, you're starting over again. The function is considered to be odd. Now, we have not talked much about odd and even. What this means is our graph is symmetric with respect to the origin, which means you could fold it on the x-axis and then the y-axis, and that would perfectly match up. More importantly, that means that sine of negative x is equal to negative sine of x. If you have to do any higher math, that will be important to you. And I do apologize again for the negatives just totally looping out there, but that's what happens. Okay, now we're going to graph cosine the same way using a t-chart once again. I'm going to pick those same values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And again, we're going to plug in and just find out what the cosine value is. So cosine of 0 is actually 1. And then I have y equals cosine of pi over 2, which is cosine of 90 degrees. And that is actually 0. And then I have y equals cosine of pi, which is cosine of 180 degrees, which is negative 1. I have y equals cosine of 3 pi over 2. Cosine of 3 pi over 2 would be 0. And then lastly, y equals cosine of 2 pi. Well, 2 pi and 0 usually give you the same thing. So that is definitely going to give me back the 1. When I graph cosine, again I'm looking at just one period from 0 to 2 pi. It sets up just like sine, but we're going to go differently. When I graph 0, 1, that is here. When I graph pi over 2, 0, that would be here. Pi and negative 1 is down here. 3 pi over 2 and 0 is back on the climb. And then 2 pi 1 is right back here. So I have cosine looking something like this. And again, I just did one period. It looks crazy over there. But it's going to continue on and repeat in that fashion. Alright, notice the period is from 0 to 2 pi. After that it repeats itself. It is also having a domain of negative infinity to positive infinity. It also has a range of negative 1 to 1. Now this one is not odd. This one is actually even. So let's correct these things. Domain is negative infinity to positive infinity. Range is negative 1 to positive 1. The period is still 2 pi. It is even, which means it's symmetric about the y-axis, not the origin, the y-axis. So if I fold it on the y-axis, cosine should match up. It also means that cosine of negative x is equal to cosine of x. So whereas sine of negative x was equal to negative sine of x, cosine is not so. It's even rather than odd. Now, there's not a lot to do in this homework assignment. What we want to do later is take this basic sine and cosine graph and learn to stretch them and shrink them and translate them and all of that sort of stuff. But in order to do that, you first have got to get these things in your head. So here's what you have to do for this weekend, this nice, long, wonderful weekend. You need to be sure that you can write down the t-chart for sine and cosine graphs that we made. You need to know your 5 basic points that we looked at. Oh, I hate it when I get that close to that thing. Your 5 basic points, particularly, and what their y values are as a result of that. So you need to know sine of 0, sine of pi over 2, sine of pi, sine of 3 pi over 2, sine of 2 pi, so that you can write that down in a t-chart format. And then you need to be able to sketch that graph, meaning you also need to be able to label your axis correctly and space it out correctly so it's nice and neat. On Wednesday, when you come back, you need to be able to do this for a quiz. We will probably do it first thing when you come into class. So be sure that you have all of that kind of gathered together. Okay, not too bad. Graphs of sine and cosine functions. This is the very basic part that we are fixing to lay out and build the rest of this chapter on. So this is very foundational. Make sure you put the time into it to do it well.